In the series RL circuit shown, the source voltage is V of t is equal to 50 sin 250t volts. Using Laplace transform, determine the current when switch K is closed at t equal to 0. So here RL circuit is given. We are supposed to calculate the current flows through in this circuit, that is I of t. It is said that the switch is closed at t equal to 0. It means that before t equal to 0 the switch was in open state, and in open state the current I of t was 0. Therefore we can say I of 0 minus was 0 amps. The current in the circuit before closing the switch was 0 amps. Now for easy analysis, let's represent the circuit in S domain. Now at t equal to 0, the switch will close the equivalent S domain circuit is shown below. Now the switch is in closed state. So in S domain the resistor value will be same, that is 2.5 ohm. Inductor value will become 0.005 S. That is, in S domain the inductor L is replaced by L into S. Resistor value will be kept as it is. V of t given is 50 sin 250t. To represent it in S domain, I suppose to write it as V of S. So V of S is nothing but Laplace transform of this equation or this value, that is 50 into, it is of form sin omega t. The Laplace transform of sin omega t is omega divided by S square plus omega square. Therefore I can write it as, here omega is equivalent to 250, that is 250 divided by S square plus 250 square. So now I have converted time domain equation into S domain. So here this will be now V of S, and V of S value is same. Now the current flowing in the circuit is I of S. I'll call it as I of S. So as I said, if there is an inductor should be replaced by S into L in S domain, or L into S, both are same. Now let's apply KVL to this loop. The analysis in S domain is simple. That's why it's good practice to convert the given time domain circuit into S domain circuit. I'll apply KVL to this circuit. That is, V of S is equal to 2.5 I of S plus 0.005 S I of S. So now let's take I of S common. We can write it as V of S equal to I of S 2.5 plus 0.005 S. Therefore I of S can be written as V of S divided by 2.5 plus 0.005 s. Now I will represent this equation as V of s divided by, I'll take 0.005 common, then I can write here 2.5 divided by 0.005 plus s. So it can be, which is equal to 1 upon 0.005 gives 200 V of s divided by, I can write it as s plus 2.5 divided by 0.005 gives 500. So I brought it to standard form, that is s plus some constant. So I of s value is 200 V of s divided by s plus 500. Now let's substitute the value of V of s in this equation and we'll simplify further. I of s is equal to 200 into V of s divided by s plus 500. Now I'll substitute the value of V of s, that is 50 into 250, 200 into 50 into 250 divided by s plus 500, which is as it is, and another denominator of V of s is s square plus 250 square. 2.5 into 10 raised to 6 divided by s plus 500 s square plus 250 square. So now if we take the inverse Laplace transform of this equation, definitely we'll get I of t. Before that, we'll simplify this equation using partial fraction method. I of s is equal to constant a divided by s plus 500 plus bs plus c divided by s square plus 250 square. Now let's calculate the constants a, b and c. So on left hand side, I of s is nothing but this entire equation, that is 2.5 into 10 raised to 6 divided by s plus 500 s square plus 250 square is equal to a divided by s plus 500 plus bs plus c divided by s square plus 250 square. So now on right hand side we'll take the LCM, we'll get it as a in bracket s square plus 250 square plus bs plus c s plus 500, and denominator is s plus 500 s square plus 250 square. Now comparing the LHS part with RHS, the denominator will get cancelled. We'll get 2.5 into 10 power 6 is equal to a in bracket s square plus 250 square plus bs plus c s plus 500 Now we'll try to calculate the constants a, b and c. So in this equation, if we take s equal to minus 500, then this term will become 0, and multiplying 0 with bs plus c, so this entire term will become 0. Then there remains only a, so we can calculate or we can find the value of a. Therefore, put s is equal to minus 500 in above equation. 2.5 into 10 raised to 6 is equal to a in bracket 500 square plus 250 square, because s is minus 500, that is nothing but minus 500 square is nothing but 500 square. Therefore, I can get a is equal to 2.5 into 10 raised to 6 divided by 500 square plus 250 square. 2.5 mega divided, or I can multiply 500 square plus 250 square inverse, that is nothing but a value is equal to 8. So we found the first constant, that is a is equal to 8. Now put s equal to 0 in equation 1, so that I can write it as 2.5 into 10 raised to 6 is equal to, here s is 0, so remaining term is a into 250 square plus here bs, this term will become 0, then here s will become 0, so we'll get 500 into c, 500 c. So here a value is known, that is 8. We can substitute 2.5 into 10 raised to 6 is equal to 250 square into 8 plus 500 c. Now with the help of this we can calculate c value, that is on left hand side 2.5 mega, that is 10 raised to 6 minus 250 square into 8 is equal to divided by 500, so which gives c equal to 4000. So this is another constant 4000. Now by substituting a is equal to 8 and c is equal to, now another constant b can be calculated as, now in this equation look at left hand side, there is only constant. Suppose the left hand side is of the form, is the equation of the form as square plus bs. In that case the coefficient of s square is 0 in this case, because here we have only constant term. When we compare that with the right hand side, here the coefficient of s square here is a, and in this term the coefficient of s square is b. So we can say the coefficient of s square on right hand side is a plus b, on left hand side is 0. So I can say a plus b is equal to 0. Therefore b can be equal to minus a, therefore b is equal to minus 8. So now we will represent I of s in this form, that is a divided by s plus 500, bs divided by s square plus 250 square plus c divided by s square plus 250 square, as we have found the values of a, b and c. I will rewrite I of s as, I of s is equal to, it is 8 divided by s plus 500 minus b value is 8, bs divided by s square plus 250 square plus c value is 4000 divided by s square plus 250 square. So now here I will try to represent each term on RHS in terms of standard form. That is, I can write it as 8 divided by s plus 500 minus 8s divided by s square plus 250 square plus, here I can represent 4000 as 4000 divided by 250 into 250 divided by s square plus 250 square. Now taking inverse Laplace transform, that is ILT, for reference here I will write the Laplace transform of few terms which have come in this equation. We know that Laplace transform of e raised to minus at gives 1 over s plus a Laplace transform of, so now I can say inverse Laplace transform of 1 upon s plus a is nothing but e raised to minus at. Similarly, inverse Laplace transform of s divided by s square plus omega square is cos omega t. Likewise, omega divided by s square plus omega square, its inverse Laplace transform is sin omega t. Now, therefore, we can say inverse Laplace transform of 8 divided by s plus 500. It is of form 1 by s plus a, which is nothing but e raised to minus a into t. So here the value of a is 500. So I can write I of s is equal to 8 is constant e power minus 500t minus 8 is constant. I will write it as it is s divided by s square plus 250 square. It is of form s divided by s square plus omega square, that is cos omega t. Here omega value is 250. So I can write minus 8 cos of 250 t. Similarly, 4000 divided by 250 gives 16. 250 divided by s square plus 250 square. It is of form omega divided by s square plus omega square, where omega value is 250. So I can write it as 16 sin 250t. Sorry, this is supposed to be I of t. Therefore, I can write it's supposed to be I of t. After taking inverse Laplace transform, I of s becomes I of t. Therefore, I of t is equal to 8 e power minus 500t minus 8 cos 250t plus 16 sin 250t amperes. This is the final answer. So by converting the given time domain circuit into frequency domain or S domain, the analysis will become simple. Thank you.